Welcome to my Introduction to Networking course, typically abbreviated ITN. This will be for the CCNA version 7 curriculum. Okay, welcome. This is Lab 9.13, Packet Tracer, identifying MAC and IP addresses. So I'm going to go ahead and launch it. I'm going to resize my window to make sure everything's nice and neat. Again, read the objectives, read the background, work through that material. So with this, we have two main parts. We have gather the PDU information for our local network and our remote network. So we're going to go ahead and we're going to work through this. Alright, so review the reflection question in part 3 before proceeding with part 1. There are a lot of questions. Were there different types of cables media used to connect the devices? IC wireless, IC straight through, IC what appears to be a fiber. So yes, we definitely do. Alright, so we're going to go ahead and answer these questions at the end. So, Part 1, given you an idea of the types of information you can gather, the PDU information as a packet traverses the 172.16.31.5 network going to the local network of 172.16.31.2. So we're going to go ahead and open up the machine labeled 172.16.31.5. That's this guy right here. We're going to get to our command prompt. And we're going to ping 172.16.31.2. While it's going, we should do simulation. So we should be able to. I hate when they do this. Let's do it again. And so we'll walk through the steps. Once I click, the screen's going to disappear, so I'm just going to go ahead and move it off my screen. We will send it to our local switch. Our local switch should get it. We'll forward it out the correct port. This is a crossover cable going to a hub. The fact that it's a hub, we'll send it out all ports because again it's a hub. Here 172.16.31.3 will receive it, but it will drop it because it's not addressed to it. 172.16.31.2 will respond. Again, the hub will send it out all ports. 172.16.31.3 again will receive it and discard it. The switch will receive it and inspect it and send it out only the appropriate port. And that completes one echo request. We can do it again. Just give it the time. Again, the hub will receive it, give it to everyone on its interface except the port that it was received on. Hubs basically just clone the signals and send it to everyone. When it's completed, that's the next packet. Again, this is going to do it for each of the 4 echo requests. At this point, I'm pretty sure we understand the process. So I'm just going to go ahead and done. Alright, so we can see the information. Our PC got it. send it out. This was our port. It's going to that port, this MAC address, that MAC address. The switch will receive it on its port. We'll forward it to the hub. The hub will receive the frame. We can see the information, the frame destination of the MAC address. The packet's destination IP address matches the device's IP address or the broadcast address. Then the device will de-encapsulate the packet and so forth. The packet is an ICMP request, so the ICMP is processed, and then an echo request is responding. So we've done that. We can inspect the different ports. We can see the MAC addresses. So again, we have our device, our destination, where is it going, our source MAC address is our machine, and then our source layer 3 data, source IP, destination IP. That's fine. The switch receives the frame with this destination address, this source MAC address. The switch will process it and will forward it accordingly. The switch knows that this is the interface where these MAC addresses reside, so it'll forward it to the next device, which happens to be a hub. Hub records nothing because it's a dumb device. The device, the PC, for example, will receive the destination MAC address and will realize it's itself, so it needs to send an echo reply. So this is going to be the replying MAC, or the new destination MAC address. This is the one that we're going to be replying to. This will be the source MAC address of the PC, and then we will then flop it. So this is now the source, because we are talking now that this machine has the packet. It has now received the packet. It's now responding to the packets. So we're going to repeat this process. Ping this machine from 3. Ping 172.16.31.2. Notice the switch will receive it, and the switch will just ignore it. That's because the hub will forward it out every interface except the one it received it on. And those are our 4 requests. If we look at it, if we break it down again, the machine goes to the hub. The hub will send it out all ports. The switch will also receive it, not recognize the MAC address, and drop it. Alright, so on PC4, ping. Oh, sorry. From PC5, we'll ping PC4. .4. Here, going from 5 to PC4, the switch will recognize it, not send it out the interface that the hub is on, because there's only one interface that has the matching MAC address, which would be the link for 172.16.31.4. So we have a little bit better direct communication. We don't have to involve the hub. and problem is done. So that takes care of our PDU information for our local communication. Now we're going to have to do the same thing, but for our remote network. Alright, so what we're going to do is we're going to go through this process again, but this time we're going to do it for a remote connection. So we are on PC 172.1631.5. We are going to ping 10.10.10.2. I know it said switch back to real-time mode and all of that, but in reality I just kept it simulation mode because I know what's going to happen. I'm going to have to go through the simulation. Our PC 31.5 will hit the switch. Our switch will forward it out the fiber to our router. Our router will receive it and then drop it. Now the second time the router will receive it and process it and forward it out its interface to its switch. Access point will get it, and then access point will act more like a hub and will send it to both 10.10.10.2 and 10.10.10.3. 10.10.10.3 will drop it because it doesn't apply to it, and then 10.10.2 will respond. Access point will respond to the switch, and access point will again respond back to 10.10.10.2 and 10.10.10.3. Both of them will drop it because this is a return trip back to 172.1631.5. This is probably an ARP request. It's to identify the address and port. And then here we actually have our completed requests. So we can see the MAC addresses, we can see the process from PC 31.5 to the switch, from the switch to the router, from the router to the remote switch, and so forth. So let's digest this. So here we have our destination device. Sorry, our device. Our device will send it to the MAC address, destination MAC address. But you'll happen to notice that this MAC address is not the router. Or is it? This is actually Fast Ethernet 1/0, the 172.16.31.1. That's because it's a remote network, which means it needs to go to the LAN side of the router. So this machine is sending it to this interface, and that's the MAC address, even though the destination IP address is the remote address. This is one LAN, this is another LAN. I take that back, and I just that's one LAN. That's another LAN. Two separate LANs. So anything leaving, I'm going to call this 2 and this one 1. Anything leaving LAN 2 has to go to this interface. which means it's going to use that MAC address interface. I'll delete all the drawings. It's good enough. So 31.5 sends it to the switch forwards it to the router checks its route table processes it, realizes it's a different network on the other side, but it is connected and it does have a route to that device, so it forwards it out to switch 0. Switch 0 will receive it, process it, send it out the appropriate port to the access point. Access point will then process and then forward accordingly. So let's look at the 20 reflection questions. Alright, so let's talk questions. So we already answered the question for number 1. And that question is, what are the different types of cables and medias used? We found copper, fiber, and we did find wireless with the wireless hub. Did the cable change the handling of the PDU in any way? So layer 1 and layer 2 are made to be independent. So the PDUs are the same. The layer 1 and layer 2 protocol being used is Ethernet. So the Ethernet frame was not modified in any way. Did the hub lose any information that it received? No, it doesn't lose anything. It just clones it and forwards it out all ports. What does the hub do with the MAC address and IP address? Nothing. There's nothing to do anything with it. The device just clones it. Did the wireless access point do anything with the information given to it? Yes, it did repack the Ethernet frame and then put it to a wireless frame. So to do this again, here we see an Ethernet 2 header. Ethernet 2 header. Here we have a wireless frame. Layer 2 is now changing it to 802.11, which is a wireless Ethernet frame. It's similar to an Ethernet, but it's not quite the same, so it will take it to an 802.11 wireless frame. Was any MAC address or IP address lost during the wireless transfer? No, it just repackages it using a different layer 2 protocol. What's the highest layer that the hub and access point used? Both of them are layer 1. Did the hub or access point ever replicate a PDU that was rejected with a red X? Yes, it did. When our access point had the return trip back to 172.16.31.5, it forwards the frame up. But it also, right here, repackages them and redelivers them back to 10.10.10.2 and 10.10.10.3, and they're both rejected. Which that's what is expecting. Why would the MAC address appear in this order? Nope, sorry, that was question 9. When examining the PDU detail tab, which MAC address appears first? It always does the destination. Why does the MAC address appear in this order? Basically, the switch can begin forwarding a frame to a known MAC address more quickly if it knows the destination. So we do destination first. Was there a pattern to the MAC addresses in the simulation? No. Did the switch ever replicate a PDU that was rejected? No. Every time the PDU was sent between 10 network and the 172 network, there was a point where the MAC address suddenly changed. Why did this occur? The switch going to the router will get the router's MAC address. When it leaves the router, it again gets a different address. What device uses MAC addresses that start with the 00D0BA? That would be the router. What device did the other MAC address belong to? To the sender or receiver, or sender and receiver. Did the sending and receiving IPv4 address change fields in the PDU? No. The source and destination IPv4 address remains the same. When the following reply to a ping, sometimes called a pong, do you see the sending and receiving IPv4 address switch? Yes, sometimes you do, as a return trip. What is the pattern to the IPv4 addressing used in the simulation? Basically, each port of a router requires a set of non-overlapping addresses or non-overlapping networks. Why do different IP networks need to be assigned different ports on the router? It provides functionality of the router to allow for interconnection with different address networks. Last question. If the simulation was configured with IPv6 instead of IPv4, would there be a difference? The IPv4 addresses would be replaced with IPv6 addresses, but other than that, no. Source and destination layer 3 addressing, that's the only difference. The layer 1 and layer 2 information remains the same. So that takes care of all of our 20 questions. That is the end of this lab. If you have any questions, thoughts, concerns, please reach out. Thank you. If you have any questions or anything, please feel free to reach out. Again, with this material, being able to ask questions and discuss some of the topics in the lecture help build long-term retention, so do not be afraid to communicate with this topic. Again, I'm here if you need anything. Thank you.